So just now we have discussed about oxides and hydroxides of alkali metals. Next we shall discuss about halides of alkali metals. The different halides are sodium chloride, sodium bromide, potassium chloride, potassium bromide. We know that sodium chloride is an ionic compound. And ionic compounds have high melting points. It is due to the strong interionic forces of attraction. So, alkali metal halides have high melting points and they are crystalline solids. These halides have high negative enthalpies of formation. Melting and boiling points of halides is found to vary in this order. That is fluoride greater than, chloride greater than, bromide greater than iodide. We know that alkali metal halides are ionic in nature. So they are soluble in water. But lithium fluoride is less soluble in water. Lithium fluoride has covalent character. So it is less soluble in water. It is due to high lattice enthalpy. Cesium iodide is less soluble in water. What is it due to? It is due to the smaller hydration enthalpies of both cesium ion and iodide ion. We know that cesium ion is the largest and iodide ion is also the largest ion. So because of the large size of the cesium ion and iodide ion, the hydration enthalpy will be very small in the case of cesium iodide and hence it is less soluble in water. Lithium halides exhibit covalent character and hence lithium halides are soluble in ethanol. Let us now discuss about the methods of preparation of alkali metal halides. Sodium chloride, for example, can be obtained by the reaction of sodium hydroxide with hydrochloric acid. When sodium hydroxide reacts with hydrochloric acid, we know that the products formed are sodium chloride and water. Now, how can we get potassium bromide? It can be obtained by the reaction of potassium hydroxide with HBr. Along with the potassium bromide, water will also be produced. Carbonates also react with the hydrochloric acid to give chloride, water and carbon dioxide. For example, sodium carbonate reacts with hydrochloric acid to give sodium chloride, water and carbon dioxide. So, alkali metal halides may be prepared by the reaction of either hydroxide or carbonate with hydrohalic acid. Salts of oxoacids. What are oxoacids? These are acids in which acidic proton is on a hydroxyl group. Different oxoacids are sulfuric acid, carbonic acid, H2CO3. So, alkali metals form salts with both sulfuric acid and carbonic acid. The salts are known as carbonates and bicarbonates if the oxoacid is carbonic acid H2CO3. These salts are soluble in water and they are thermally stable. Now consider different carbonates, that is carbonates of different alkali metals. We have lithium carbonate, sodium carbonate, potassium carbonate, rubidium carbonate, cesium carbonate. The stability of these carbonates increases with increase in electropositive character. Now we know that as we move down the group, electropositive character increases. So as we move down the group, since the electropositive character increases, the stability of carbonates increases. Lithium carbonate is not stable and it decomposes to lithium monoxide Li2O and carbon dioxide. So if we have lithium carbonate and cesium carbonate, the most stable carbonate will be cesium carbonate. It is because as we move down the group, the stability of carbonates increases. Anomalous properties of lithium. The different alkali metals are lithium, sodium, potassium, rubidium, cesium and francium. So lithium is the first element among alkali metals. And anomalous properties of lithium is due to its small size and high polarizing power. Being the first element among alkali metals, lithium differs from the rest of the alkali metals. So let us now discuss the points of difference between lithium and other alkali metals. Lithium is harder and it has higher melting and boiling point compared to other alkali metals. Lithium is the least reactive element and it is the strongest reducing agent. Lithium forms lithium monoxide and lithium nitride. Lithium chloride is deliquescent. So lithium chloride exists in the form LiCl.2H2O. It exists as a hydrate. Lithium hydrogen carbonate does not exist in the solid state. Ethanide is not formed with ethine. Consider lithium nitrate LiNO3. When heated, it decomposes to lithium monoxide Li2O, nitrogen dioxide NO2 and oxygen. Whereas sodium nitrate, when heated, decomposes to sodium nitrite NaNO2 and oxygen. So these are the points of difference between lithium and other alkali metals.